Okay, so we're going to look at another quadratic inequality here, and just like last time, okay, we're going to focus on those critical points, because ultimately we do want to solve this inequality, don't we, such that it's less than or equal to 0. But let's just focus on those critical points, as I said, on the sort of border. Let's find what they are. So in other words, let's solve this quadratic equals to 0. So again, we're going to have two brackets with x in both of them, okay, and we need to have two values that multiply to give 6 and add up to give -5. Now we've got to be really careful here, because 1 and 6 multiplies to give 6, yeah, and you could get -5, couldn't you, from these, okay, if you made that a minus, but that would have to be a plus. The issue you've got then is -6 plus 1 does give you this, but when you times them, it doesn't give +6, so that's no good. So the other two values that multiply to give 6 are 2 and 3, and that will work, won't it, if you make them both negative, because -2 minus 3 gives you -5, and they both multiply them, it gives +6, yeah, because a minus times a minus is positive. So -2 -3. So again, just like before, you've got two brackets equal to 0, so either the first bracket has got to be 0 or the second bracket has got to be 0. So in other words, x is equal to 2 or x is equal to 3. So we're going to do a sketch then of what this curve looks like. Now, I know now where the curve crosses the x-axis, okay, because those are my critical points here, so 2 and 3, okay. Now don't worry about the scale, that's not important, this is just a sketch. And we want to solve then this situation here where it's less than or equal to 0. So in other words, where the curve is negative, so it's going to be this bit here, yeah? So we need these x values in here, because if you go to the x values outside, then outside of 3, beyond 3, it produces positive values, and if we take x values which are less than 2, again it produces positive values, so we need to be greater than 2, okay, but also we need to be less than 3. Now if I write the solution here, if I say x is greater than or equal to 2, okay, right, which would be true there, yeah. Look at this situation though, x has got to be less than or equal to 3, okay. Now if you're going to leave your answer like this, it's so important that you put the word "and" in the middle, okay. The reason why is if you look at this here, it says x has got to be greater than or equal to 2. Well, that means x could be anything beyond 2 if you just leave it like that, okay. So x could be 4, couldn't it? X could be 10. But that doesn't quite work, doesn't it, with what we've got here? X has got to be greater than 2, but it's also got to be less than 3. So if we put the word "and" in, then those two situations have to qualify. In other words, x has got to be greater than or equal to 2, but it's also got to be less than or equal to 3. So these two things have got to be work in tandem, okay? So it's okay to say this, so long as you say this in conjunction with it, okay? So both are true at the same time, okay? So in other words, x is greater than or equal to 2, and x has got to be less than or equal to 3. Now, a better way of writing it is to combine these. So what I always do is, I look at the highest value, which is 3, and I say, look, x has got to be less than or equal to 3, and I copy that inequality here, and then I say then it's greater than or equal to 2. So that's a better way of writing it. So you just say x essentially is greater than or equal to 2, less than or equal to 3. So x is between 2 and 3.